All right. Good evening, guys. Good evening. Please confirm if you can hear me, please. Let me know if you can hear me. All right. Good evening. Thank you, Pamela. Good evening, Cecile. Good evening, Jane. Good evening, Tupsi, Caroline. Good evening, Aderonke. Hot topic. Good evening. How you doing? Onyekwere Miracle. Good evening. Good evening. Thank you very much, Aderonke. Okay. Good evening, Ebunoluwa Daniel. Good evening, Tony Olorunfemi. Good evening, Gifts. Yeah, thank you very much. My day was quite interesting. It was eventful. Yeah, but here we are. We thank God. Thank you very much. All right, quite eventful, Tony. Quite eventful. Well, bless God. We are here. Yeah. Okay. So here's what we do. Let's give others grace of a few minutes to join us. So let's wait for 3 minutes. So by 7 minutes past seven, my time, we will commence. Yes. So we are almost done with cloud security fundamentals. Okay. Yeah. So we're almost done with the fundamentals, and hopefully we will be rounding up with that today by God's grace. We don't have much left in our slide to cover, so I believe we are very good to go. All right, so you guys just catch up. Tell me, I trust that you guys are reading beyond this class, right? I trust that you're consuming resources beyond this class. Okay, so please, if you have anything interesting you saw while studying, please feel free to share with us. And even as we wait, okay, yes, thank you. All right, so yeah, let's wait for 2 more minutes and then we'll start. Okay, all right. Okay. Yeah, good evening, Juliet. Ode. Yeah, my day was interesting. Thank you. It went very well. Thank you. Good evening, Obinwene. Yeah, is my voice bad? Okay. Yes, I'm doing very well. Thank you. All right. Good evening, Joy. Good evening, Adebanke. Good evening, Second Joy, the other Joy. Good evening, Osimen. It's been a while since I saw your comment, Osimen. Good evening, Grace, Elsie's Diary. Good evening. Good evening, Ade Shola. Good evening, Priscilla. Good evening, Obaru. Good evening, Boluwatife. No, just a little drizzle here and there, drizzling here and there. All right. So I believe we can start. So let's do a little recap. Let somebody drop a few things. Let's do a little recap. Drop. You guys should drop some things in the comments. Let's do a recap before I go through the slide, and then we get to what we have for today. So please, I'll be happy to read your comments, guys. Yeah, good evening, Ivy. Good evening, Temitope. Good evening, Oluwafemi. Good evening, Jesu Gbemisola. Dolapo. Good evening. So I'm waiting for your comments, guys. All right. All right. Thank you, Owolabi Community Cloud. Yes, I think we spent a few minutes on Community Cloud. Yeah, thank you, Hot Topic. Community Cloud, more than one organization coming together to set up cloud infrastructure. Apt, very well said. Right. Okay, thank you, Jane. We started with Community Cloud, the key features, the benefits, the challenges associated with Community Cloud. All right. Good evening, Jesu Tomini. Um, Good evening. Okay. Obiwe name, we talked about cloud computing, which is the delivery of computing services such as storage, servers, databases, networking, and thank you. Very well said. Yes, I love it. I love what you just wrote. Yes, thank you very much. Jesu Gbemisola, cloud security. Good evening, blessing. Okay. They have common concerns. Yeah, well said. Hot topics, security, compliance, industry specific requirements. Okay, yes, we learned fundamentals. Yes, I love this. Yes, the fundamentals. We've not gone too deep into it. We are just touching the surface. We are trying to understand how it works and see how we can take advantage of it. All right. Joy Community Cloud can be managed internally. Yes. Very well said. Um, Good evening, Ade Oluwaseun Folorunsho. Good evening. My day was fine, thank you. Priscilla, public cloud, they are owned and operated by third-party cloud service provider. Well said, Priscilla. Thank you. Gifts. Under fundamental cloud security, we learned about shared responsibility, identity and access management, its components and best practices. Yes, thank you. Oh, good evening, Titilayo. Yes, it was fine, thank you. Good evening, Emilia. Good evening, Jimmy. Good evening. Okay. Juliet Ode, challenges of cloud computing, challenges of yes, very well said, Juliet and Wola Bitemitokwe. Okay, we learned the differences between private and public cloud computing, and community cloud computing. Yes, thank you very much, Blessing. Thank you very much, Blessing. Okay, I love the comments coming in. It means you guys are actually following. Okay. Yes. Okay, now Flourish has changed the conversation. Was thank you, Flourish. Good evening. Hybrid cloud combination of private and public cloud. Yes, Juliet benefit of cloud computing, Osime benefit of community cloud is cost saving. Yes, somebody made a funny joke yesterday. I can't remember who that was, where I said, "Well, I don't have enough money." And when I was explaining, the person said, she said she has all the money that is needed. If you are the one, please identify yourself. That was a very nice joke. Okay. Yes, thank you, Adirunke. We learned about cloud service model. Yes, thank you. Yeah, thank you, Pamela, in benefit of cloud computing. Hmm. You guys are actually paying attention. I think I'm getting more familiar with more names. Yes, and I'm happy that is happening. Yes, hot topic IAM, identity and asset management. Okay. Yes, CIA. Jisugbemisola. Yes, CIA. Good evening, Taiwo. It is access management, identity and access management. Hot topic. Okay. Yes, Miracle. Thank you. CIA triage. Okay, thank you very much, guys. I think I will stop taking comments now so we can get to what we have for today. Okay, so we've gone through a quick recap. I would have gone through my slide, but that is over 100 pages of slides. So, and you guys have done justice. Yes, you guys touched most of what the things I would have spoken about. So that's really nice. So let's move forward. So securing cloud application, we'll start by securing cloud application, touch a few things, then go on break, and then we will get to the business of the day, which is identity and access management in the cloud. Okay. All right. So let's move. So application security fundamentals, right? Application security involves protecting applications from vulnerabilities. So we touched a few things yesterday, right? We did some introduction. So we are going to be building on some of the topics we touched yesterday. I remember somebody asked about SAST, DAST, and I asked that the person do a little research. So I trust that you have answer to that already. Please, if you are the one, kindly drop the answer in the comment section. I will be looking through the comment section for your answer. Okay. Yeah. So one of the things we touched was application security, and then we said, okay, there's DAST, dynamic application security testing, there's SAST, static application security testing, right? So today we'll be going a little bit deeper, right, than we did yesterday on application security, right? So application security involves protecting applications from vulnerabilities and threats throughout their life cycle, right? So from beginning of application development to when product is being launched, we have to make sure that we properly protect it from vulnerabilities and threats. So from the development to deployment and even beyond, right? Ensuring the application, ensuring the security of applications is essential to protect sensitive data, right? So most time when people hear about hacking, the only thing that comes to their mind is, oh, somebody is stealing money. No, hacking is actually beyond stealing money. There are far more valuable information, there are far more valuable data, right? That can be stolen, that can be very detrimental to the image of an organization. So it's not always money related, right? Sometimes it has to do with integrity. You get, remember the CIA triad. If you can mess with confidentiality or integrity or availability of data, then there will be trouble. So ensuring the security of applications is essential to protect sensitive data, maintain user trust, and comply with regulatory requirements. So we'll be looking at some key fundamentals of application security. So we'll be looking at some key fundamentals of application security. So the very first one, we have software development lifecycle in the cloud. Remember that our conversation right tonight is in the context of cloud. You get, so we have software development lifecycle (LDLC), right? So you must make sure that there's secure development practices, like you follow secure development practices. So secure development practices aim to integrate security into every stage of the software development lifecycle. So it is not when the organization, it is not when the developers are done building the software, right, that we now decide to start checking for security. That's where we start considering security. We must make sure that even as development is going on, security is also integrated into the process. Okay, so secure development practice. Okay. Next, we have authentication and authorization. So we must make sure that there's strong authentication and authorization mechanisms. And we must make sure that strong authentication and authorization mechanisms are essential. So this is essential to ensure that only legitimate users can access the application and its resources. So we must make sure that it is properly integrated into the application that we are building on the cloud, the application that we are putting into the cloud. So the fact that you are putting it on cloud, the fact that you are putting it, exposing it through the cloud doesn't just automatically make the application secure. So you must make sure you do your part, right? Proper authentication and authorization, right? Okay, then now when you have applications on the web, right? When you have applications on the cloud, you must make sure that there's proper input validation and output encoding. So validating input and encoding output are critical to prevent against injection attacks, right? And cross-site scripting. So cross-site scripting is an example of an injection attack. So you must properly check, right? You must properly validate. You must properly validate what the user is supplying to the application, right? And then also you must properly encode the information that is coming as an output from the application. Okay. Yeah. Then we have secure communication. Secure communication. So now secure communication ensures data is protected in transit between clients and server. So definitely there will be conversation between the user of the application that is being hosted on the cloud and sorry and the application itself. So we must make sure that the flow of this information between client, which is the user, and the server, which is the infrastructure that is in the cloud, or the asset that is on the cloud or in the cloud rather, that this data is properly protected while it is traveling. So how can we do this? We mentioned some of it yesterday, which is transport layer security, TLS, right? So you must use TLS to encrypt data in transit, so you don't just send information in plain text. Then you need API security. So a lot of organizations these days, right, are using API because it helps to remove a lot of hassle in the software development process. So and compatibility problems. Okay, so secure APIs with proper authentication. So don't just assume that, oh, since people can't physically see the API, it is secure. No, people, bad guys have the right tools that they can use to import the API, that they can use to interact with the API, even if there's no proper user interface. So secure APIs with proper authentication and authorization and encryption. Then we have certificate management. Okay, so you must ensure that you use valid and up-to-date SSL and TLS certificates. So don't just say, oh, I'm using SSL, I have TLS on this infrastructure, so I don't need to disturb myself again. No, you must make sure that it is up to date. Your SSL certificate, your TLS certificate is up to date. Okay. Next, we have session management. Session management. So proper session management is essential to protect user sessions from hijacking and other attacks. So we have multiple persons, multiple personnel that will be using this application that is being hosted on the cloud. So we need to make sure that there is proper segregation between the different user session. So Emmanuel is browsing, Miracle is browsing, Juliet is browsing, Grace is browsing. We must be able to tell the difference between these different users. Okay, so this can be handled by proper session management. So we manage each user session properly. So it is essential to protect user session from hijacking and other attacks. So Emmanuel should not be able to meddle into hot topics session and thereby stealing our information or thereby hijacking a session. So how do we go about this? We use secure cookies. So use secure attribute for cookie. So things such as HTTP only, that means somebody cannot access the cookie can only be accessed through HTTP session. So this helps prevent things like cross-site scripting and a couple of other vulnerabilities. Then we have session timeout. So you must implement session timeouts to automatically log out inactive user. So if a user stays idle for X amount of time, then we know that, oh, we should log out this user because this user might leave their device and then maybe another person can come and then probably try to be funny. Then next we have session IDs. So use unique and unpredictable session IDs and regenerate them after authentication. So your session IDs should be unique, it should be unpredictable. So you don't go using session ID 1, session ID 2, session ID 3 to determine users. No, if you are using something like that, it is easily guessable, it is easily predictable. So if I'm browsing and I see that my session ID is 1, then I know that I'm sorry, is 4, then I know that there's a high chance that maybe the next number, which is 5, belongs to another user. So I could try changing my session ID to see if I can get into the user's account. So we must use something that is unique for each user, right? It's not just unique, it's also unpredictable. Unpredictable, very, very important. So it's going to be a bunch of random text that I can't make sense out of. Right? Then we have error handling and logging. This is very important. So you must make sure that there is proper error handling. So effective error handling and logging can help identify and mitigate security issues while preventing information leakage. So if your application, you must make room for when your application runs into an error. So it's not that, oh, your application runs into an error and then is vomiting all this essential information, all the critical information about itself. No, so you must make sure maybe there's a custom message, there's a custom error message that, oh, even if a normal user is using the application and then they run into an error, there is no harm that is going to be done as a result of this. And then you have to also make sure that you log things properly. So should in case you get there's a malicious user that is misbehaving right on your application, which is on the cloud, you can actually check your log and detect this person, and then from there take the necessary action. Okay. So generic error message. So avoid revealing detailed error information to end users, right? Then centralized login. Implement centralized login to monitor and analyze security events. All right, then log sensitive action. So you must log sensitive actions such as authentication attempt, access control changes, and data modification. So this is very important. So you can tell who is who on your application, and you can also tell exactly what is happening in your application. You can tell the exact time that somebody tried to play funny on your application. Okay. Now, secure configuration management. So secure configuration management ensures that applications and their environment are configured securely. So you must make sure that the configuration being done in the environment is done securely. It's not just, oh, it is working, so we are good. No, no, no. We must make sure that it's working the best way that it should, right? So it's not just, oh, let's do over here in Nigeria, we have a word called wuru. Let's do wuru, right? Let the application be working. As long as it's working, then we are good to go. No, no, no. Must make sure that the application is working the way it's supposed to work, right? That means our configuration is correct. So how do we do this? There must be a configuration baseline. Must have something that we can use to tell this configuration is done correctly. This configuration is insecure. So we must establish and ensure secure configuration baseline. So whatsoever anybody is doing on the cloud platform, we must have something to tell. Okay, you've done the right thing. We must have a way, a baseline to tell that you've done the right thing, you've done the wrong thing. Okay. Then we have least privilege. I believe we know this already. So apply the principle of least privilege. Okay. Right? Then environment segregation. So separate development, testing, and production environment. You must make sure that things are properly segregated. Development environment is different from testing environment, and testing environment is also different from production environment. Okay. Oh, all right. Okay, skip 7 and 8. Let me check. Sorry. Sorry. Sorry, guys. That is a typo. Is a typo in my slide. Thanks for noticing that. Sorry, it's a typo. Okay. So so principle of least privilege. So the user only have the right to do what they should be doing. So you shouldn't give them overly excessive permission, right? And then proper environment segregation. So we make sure we know that a lot of changes, a lot of things are going to be happening in the development environment. So we have to put that different, separate. Okay. So separate that, testing environment to separate that, and finally production environments, which is the environment where the final application is. We separate that also. So we know that, oh, if there's any problem arising from any of this environment, it is not going to affect the other one. Okay. All right. All right. So yes, that is it for more information concerning secure development lifecycle for application security. So next now we will be moving to common application vulnerability. We'll be moving to common application vulnerabilities. But before then, I would love to take a few questions from you guys a few contribution while we jump to OWASP top 10. Yes, so if you've heard of OWASP top 10 also, please feel free to drop your comment. Please don't quote my slide. Yes, because I know I'm displaying it already. Don't quote my slide. Tell me what you know about OWASP top 10. Let's share idea in the next 2-3 minutes, and then we'll get back to the slide to move. All right. Okay. Miracle Onyekwere. I've heard about OWASP Zap proxy, but I don't know what that is. Okay, so that's a security tool. That is a web application testing testing security tool. Okay, excuse me. Yes, so that is a tool. Okay, that's a software. Okay. So how do we detect vulnerabilities in cloud computing from Florence? We've mentioned a few things, right? So you could carry out a test yourself, right, using a couple of tools. You could also use some inbuilt tools. You could also use some SIM tools, right, security information and event management tools. Okay, so thank you. Gift, sir. So we use session timeout to avoid spoofing. No, not necessarily spoofing. Not necessarily spoofing. No. Okay. Happiness, peace, Odogu. Sorry, Ogudu. No idea, sir. All right, no problem. I love that you are saying this happiness. That's why we are here today. So if you have no idea, it's perfect. Okay, Juliet. Does it mean that every pop-up cookie means that the site is secure? No, 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 no. Does it doesn't cookies doesn't automatically make a site secure. Okay, so basically cookie is used for different purpose, right? So cookie is used for session management. It's used to track what a user is doing and can do on a website. You get, it's also used to know who is who on the website. So I mean, a bad guy can also set up his website and use cookies. You get. Okay. um Happiness, peace. All right, all right, okay. Welcome, Happiness. Eunice, OWASP is a non-profit foundation dedicated to improving. Well, very well said. Very well said, Eunice. Thank you very much. Yes, yes, very well said. Very, very correct and accurate. Damilola, when you accept cookies on a site or does or do not, okay, okay. So like I said, cookies used to track a user session, you get. So now there are a cookie can have several parts, right? So a cookie can in some websites, maybe they want to get some information about you, right? So they do this using the cookie. So those cookie, when you accept it, is like, okay, I give you consent, right? I give you the consent to take this information about me. So when you reject it, it's like saying, oh, consent to take this information about me. Okay. So it depends. It depends on the situation you find yourself, right? So it's just, oh, I give you consent. I do not give you consent to keep my data, to track my data. You get, some websites will allow you continue using them without accepting cookie. Some other websites will kick you out. Yes, let's just use that word. They'll kick you off the website. Okay. Okay. Blessing. OWASP is a global, not-for-profit organization focused on improving software security. Yes. Thank you very much, Blessing. Thank you. Beautiful. Okay. Hi, Victoria. Adefioye, I'm not hearing anything again. Okay. Are you sure? Can you guys hear me? Please, let's be sure you cannot hear me. Okay. All right. Obiwene. Yes, definitely. Nessie cookie increases catch, right? Because remember, that's what they are using to track what you are doing on the website. So, I mean, the more you accept, the more activities you perform on the website you get, the more it is. Okay. All right. Thank you, Pamela. OAPS is a non-profit that improves web application security. All right. Okay. Thank you. Thank you. Thank you. Okay. Thank you, guys. All right. All right. So let's move. So OAPS, common application vulnerability. So we'll be looking at OWASP subterm. You guys have rightly said OWASP is an organization, a non-profit organization with the sole purpose of increasing web application security. So OWASP, which stands for Open Web Application Security Project, they have what we call OWASP top 10. So OWASP top 10 is a widely recognized standard. So this OWASP top 10 is a standard for identifying the most critical security risks to web application. Identify the most common, the top 10 common security risks to web application. So understanding these vulnerabilities help developers and security professionals build secure application. So here's just a quick explanation of what how OWASP subtem works. So from time to time, I think in the space of 2 or 3 years, right, OWASP think of it as they give out a survey, and then security experts report their top find, right? Their top find web application vulnerabilities. Now, OWASP then curates this data, and then they're able to tell you, okay, this particular vulnerability is number one, right? Because a lot of persons keep finding this vulnerability. This particular one, this other one is number two, right? Number three up to number 10. So the thinking behind this is that, oh, if a lot of people, right, from different parts of the world are reporting the same vulnerability, that means there is a high chance that more persons are going to make the same mistake. There's a high chance that when you as a security professional is is testing an application, when you as a security professional are testing an application, right, is testing an application, there's a high chance that you will find one of these top rated vulnerabilities. That doesn't mean that there are no other vulnerabilities to hunt for in an application, you get. But then, oh, since a lot of persons are finding this in a lot of environments, so there's a good chance that you might also find it in the environment that you are trying to protect. Okay, so now we will be looking at a few of them. So we have injection vulnerabilities, right, under OWASP top 10. So these are the vulnerabilities you should be looking out in the application that you are trying to protect on the cloud. So we have injection vulnerabilities such as SQL injection, NoSQL, OS command injection, LDAP injection, right? Which occurs when untrusted data is sent to an interpreter as part of command or query. So the impact of this is that an attacker can execute arbitrary command. The attacker can read or modify data and gain unauthorized access to the system. So how then do we prevent this for an application, for our organization application? We must use queries or prepared statements. So we must make sure that inputs and then employ object relational mapping frameworks. Okay, so next we have broken authentication. Broken authentication. So broken authentications allow attackers to compromise password, keys or session tokens and assume other users' identity. Okay, so the impact of this is an attacker can gain unauthorized access to users' account and sensitive information or data, right? So how do we prevent broken authentication? So we must implement what? Multi-factor authentication, must use we must have strong password policy in the environment, and then we must make sure that our storages are properly secured. Okay, then monitor and log authentication attempts. Okay, my network cut off. Okay. Sorry, guys. Sorry about that. So, injection. Okay, so let's just go over it again. So, injection flow, right? This a lot of time when we are talking about injection vulnerabilities, it always comes from user supplied input, user supplied information. So we have different vectors through which this can happen. So we have injection flows such as SQL injection, NoSQL injection, OS command injection, LDAP injection, right? Which occur when untrusted data is sent to an interpreter as part of command or query. So when the user is supplying information to the application and they intentionally include malicious input. So definitely you probably have visited some website and then maybe when you are trying to enter some characters, they tell you that, oh, these characters are not allowed in this application. So most at that instance, right, the application is trying to prevent you against an injection vulnerability because there are some special character that is successful. So how do we protect against this thing? We must make sure that we use parameterized queries and prepare statements. So we prepare the statement at the back end, the SQL statement at the back end properly, right? Then we validate and we sanitize all user input. So whatsoever it is that the user is supplying to the application, we check through it and we make sure that there is no harmful character in the user supplied input. And then finally, employ object relational mapping frameworks. Okay, so broken authentication, we touched this already. So sensitive data exposure. Sensitive data exposure. So sensitive data exposure occurs when applications do not adequately protect sensitive information such as financial, healthcare, or personal data. So we must make sure that whatsoever information that we are putting on the cloud, right? Whatever sensitive information that we are putting on the cloud must make sure that it is not exposed. So a lot of times this as a result of what? Broken authentication. So attacker can steal or modify this sensitive data, leading to fraud or identity theft or regulatory fine. Remember that if you get caught, there's an amount of money that you are going to pay. Okay, so how do we prevent this? How do we prevent sensitive data exposure? Encrypt sensitive data at rest and in transit. So why are we encrypting data at rest? Right. So in case, right, we know that there's no absolute state of security. In case our data gets exposed, in case maybe a bad guy is able to compromise the organization, when they come across this data, it's not going to be useful to them. It's not going to be useful to them. Okay, then use strong encryption algorithm. All right, please, can you guys hear me now? Okay, so use strong encryption algorithm and manage key securely, and then implement proper access control. Okay, all right. Thank you, sir. All right, sorry guys, so sorry. My network is fluctuating here. I think the weather is not the nicest this evening. Please let me know if you can hear me, guys. Sincerely apologize for the breaking transmission. Let me know if you can hear me, guys. Please, can you guys hear me now? All right. Thank you, Caroline. Thank you, Simi Leoluwa. Okay, I think I'm just seeing this name for the first time. Thank you. Thank you, Jimmy, Deborah. All right. Thank you, guys. So let's get back to it. Um, so we must get that first one. Yes. Okay. So injection, right? I believe I explained the part that our user supplied input can be is where problem comes from, right? So we must make sure that we properly vet what users are supplying to the application, because there are some special characters that if introduced into the application and processed in the back end, right, they can affect the flow or the behavior of the application, right? So through these special characters, attackers can execute arbitrary commands. They could read or modify data on the system, or they could even gain unauthorized access to the system. Okay, so how do we prevent this? Right, we explained that you use parameterized query and prepared statements. So you make sure that your back end statement is well structured. You prepare it correctly so that if any user should try anything funny, it doesn't um, disrupt the flow of your application. And then also you must make sure that you validate and you sanitize all the user supplied input, all users input. You must make sure that whatever it is, if any user should try to be funny, if any user tries to um, submit malicious character to the website, you have a mechanism in place that is going to remove this malicious character, right? And then employ object relational mapping frameworks. Okay, so I believe 2 is as clear as it should. So let's move to 3, right, which is sensitive data exposure. So sensitive data exposure occurs when applications do not adequately protect sensitive information, right? So when an application is not protecting sensitive information, right, it leads towards sensitive data exposure. The information that is supposed to be private ends up being public. Okay, so attackers can steal or modify this sensitive data, right? Thereby leading to fraud, thereby leading to identity theft, right? If I can get sensitive information about you, maybe your social security number, and for those of us in Nigeria, maybe your NIN or your BVN, right? That means there's a high chance I can impersonate you when registering online, right? So how do we prevent this? We must make sure that these informations that we are collecting from users, these informations that we are collecting from users and storing on the cloud, right? We make sure that we encrypt this sensitive data at rest, and even when we are transporting it, even while it is in transit. Okay, we must use strong encryption algorithm and manage the keys securely. So I still kudos to Peace for doing a very good job in cryptography. She taught you how to do public private key encryption and all those stuff. For private key encryption, for you must make sure that your private key is kept securely. So I believe a lot of us understand what I mean here. And then you must implement proper access control. Proper access control. So not just anybody should have access to this sensitive data. Okay. Next, we have XML external entities, right? So XXE, right? So XXE attacks occurs when an application processes XML input that includes references to external entities. So XML is a type of file. It's like a file extension, right? So the same way you upload PDF, the same way you upload Word files, right? It is also possible to upload XML inputs, right? XML files, you get. So you must make sure that attackers can, the impact of this is that attacker can exploit this to extract data, right? They can execute remote requests or cause a denial of service. Okay, so how do we prevent this? We must disable external entity processing in XML parsers. We must validate and sanitize XML inputs. Then we must use complex data format, less complex data format such as JSON. So JSON is another file extension, is another data processing format. Okay. Then we have broken access control. So broken access control occurs when restrictions on authenticated users are not properly enforced. So broken access control occurs when restrictions on authenticated users are not properly enforced, right? So I will explain this very soon. Okay, so attackers can gain unauthorized access to restricted function and data, right? So for example, we are all using a website, right? Maybe a banking application, right? That means I should be able to see my account balance, but I should not be able to see Pamilarin's account balance. I should not be able to see Keziah's Alkali account balance. I should not be able to see Victoria's account balance. So if it is possible for me to see the account balance of other users, then there's what? Broken access control, right? That means the mechanism that is supposed to control my access to data on the application is failing. It is broken. You get? So I'm not supposed to have access to this data, right? Access to this data is supposed to be restricted to the owner alone. Now, not just data, there's also some special functions on the application. You get maybe some functions that might be restricted to the admin user alone. So how do we prevent this? We must enforce access control consistently across the application. So we must make sure that, oh, access control is not just limited to what? To login. It is not just limited to authentication, right? Okay, then we must use a centralized access control mechanism and perform regular access control review and audit. All right. Okay, so let's take a quick break here. Let's go on our short 10-minute break, guys, and then we will be back to finish up with OWASP top 10 and as related to the cloud, and also touch a little bit more on identity and access management in the cloud. That is our major point of discussion tonight. All right. So thank you very much, guys. We will be back in 10 minutes from now. So that will be 10 minutes past 8. We will continue our session. Okay. Thank you, guys. All right, guys, break is over. All right, please, can you all hear me? All right, thank you very much, guys. Thank you, thank you, thank you. Okay, so that's it for broken access control. Next is security misconfiguration. All right, so security misconfiguration arises from insecure default configurations, insecure configuration, or ad hoc configuration. So default configuration is good, but leaving things default is not the best of practice, right? So you must make sure that your configuration is done. The configuration of the application you are putting on the cloud is done properly, right? So the impact of this is that attackers can exploit misconfigurations, right? Setting misconfiguration settings to gain unauthorized access or control over the application. So how do we prevent this, right? Establish security configuration baseline. We touched this already when we're talking about SDLC. Regularly review and update configuration. Use automated tools to verify configuration. Okay. Next, we have cross-site scripting, which is a type of injection attack. So XXX, cross-site scripting is short for XSS, right? XSS vulnerabilities occurs when an application includes untrusted data in web pages without proper validation or escaping. So when you are taking input from users, right, you need to make sure that you properly sanitize them. Like we said, right, you need to make sure that the users are not entering malicious character into the web application, into the application in general. So the impact attackers can execute malicious script in the user's browser. So cross-site scripting is what we call a client-side vulnerability, right? It doesn't affect the server, but rather it affects the user's browser. So now, since it's affecting the user's browser, it is possible for the attacker to use it to steal the user session token or to redirect user to malicious websites. Okay, now for prevention, how then do we prevent this? We need to validate and escape all users' inputs. So proper user sanitization. We've been hammering on this over and over again. So whatsoever the user is entering into your application, you must make sure that you keep it in proper check. Okay, then implement content security policy, CSP. Then use frameworks that automatically escape XSS by design. Okay, then insecure deserialization. So in this insecure deserialization flaw occurs when applications deserializes untrusted data. Now by deserialization, it's like scattering, it's like breaking the um, data into different parts, right? So leading to remote code execution or injection attack. So attackers can structure an input in such a way that, oh, when it is being deserialized, right, it triggers or it runs remote code on an application, right? So how do we avoid this? We must make sure that we avoid deserializing untrusted data. We must use serialization methods, right? We must validate and sanitize the serialized data. Okay. All right. So next, using components with known vulnerabilities. So applications often use third-party libraries or frameworks with known vulnerabilities, which can be exploited by an attacker. So before your organization uses a framework, before your organization uses a software, before your organization uses a tool or even a library in their code, you must make sure that proper investigation has been carried out on that particular library framework or what have you, and then you are sure that there is no known vulnerability on that library. Okay, so what is the impact of this? Exploiting known vulnerabilities can lead to various attacks, including remote code execution, data breaches, or system compromise. So how do we prevent this? We must regularly update and patch all application dependencies. Use dependencies checking tools to identify vulnerable components. So you scan the application from time to time to know, okay, which dependency in this application is now vulnerable. When you detect them, then you do what? Patch management. Then you do what? You do updating. You update the application. So then also remove unnecessary dependencies and libraries. If there's any library or dependencies that is of no use, then why put it there? Why not remove it? Okay. Okay. So last but not least, insufficient logging and monitoring. So insufficient logging and monitoring can prevent timely detection and response to security incidents. So you must make sure that things are being logged and monitored properly using some readily available tools on the cloud service or the cloud platform itself. Okay, so if you do not have sufficient login, then it will be hard, right? And it will be disastrous to when you are just detecting an attack that has happened a long time ago. Okay, so the impact, delayed detection of security breaches can lead to extensive damage and data loss. Right? So how then do we prevent this? Implement comprehensive logging and monitoring. Must implement comprehensive logging and monitoring, and then regularly review and analyze log for suspicious activities. So from time to time, go through the log. Is there anything suspicious? Is there any malicious behavior? Right? Is there any malicious user? You get, those are things you should check from time to time. Review the log regularly. Then establish an incident response plan and perform regular drill. Okay, so yes, I believe we've done justice to the drilling aspect and planning for incident response. So let's not dwell too much on that. Okay, let me go through the session. Juliet Ode, does it mean man in the middle works with the use of cross? Yes, cross-site scripting is one of the ways of carrying out man in the middle attack. Yes, that's one of the vectors used for man in the middle attack. Okay. All right, so thank you guys. So yes, I will give you a little bit of assignment. Yes, in your free time, please study further on DevSecOps. Just read introduction, right? Study further on DevSecOps and continuous security. Okay, I am fast. Sorry about that. Pearl, okay, I will work on my speed. I will work on my speed. Right. So in your own free time, check online what can you see on DevSecOps, right? We won't be able to touch these, but these are also interesting things, right, that we should look at. So look into it, also look into CI/CD pipeline, right? So how do we integrate security into CI/CD pipeline? So yes, all right. So yeah, we are finally here. Okay, okay, okay. Now I know you guys are going to scream at me for my slide. Okay. Give me a minute. Let me quickly touch my slide. The font is small. Give me a minute. Let me quickly increase the font. Okay. Okay, guys, I'm still here. Okay, let me go back. Now I'll soon display the assignment again, guys. I just want to increase my font size for this next couple of slide. It's not um okay. Okay, so you should see my slide up now. Okay. All right. All right. Thank you guys. Thanks for putting the assignment in the comment section. I appreciate. Thank you, Temitope. Thank you, Boluwatife. Baron, thank you. Baron, you're always picking up on me, but thank you. Okay, you're always picking on me. Thank you. Thank you, Boluwatife. Bell. Okay, Juliet. Yes, give it a minute. It's coming up. I projected already. You should have it up anytime soon. Please let me know if you can see my slide now. All right, all right. Thank you, Pamela. So I need more comments. Can you all see my screen now? Okay. All right. Thank you, Evania. Evania, thank you. Blessing. Okay. Pamela. Okay. Cool. 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 I believe we are good to go. So this is the first one. Please take a screenshot, and then this is the second. This is the second one. All right, so I believe we've all documented the assignment. So let's proceed. So introduction to IAM on cloud. So IAM is a comprehensive set of processes, right? Policies and technologies that manages digital identity and regulates access to an organization's resources. So let me go over it again. IAM is a comprehensive set of processes, right? It involves processes, policies, and technologies, right? That manage digital identity. Take note of the word digital identity. Doesn't just manage it, it also regulates access to an organization resource. Okay, I'm working on my speed, Priscilla. It's also so let me go over it again. IAM is a comprehensive set of processes, policies, and technologies that manage digital identity. Very important. Digital identity, right? And regulates access to an organization's resources. Okay? It also what regulates access to the organization resources. So you notice that a lot of time as we're moving through the slide, right? Through the training, we mentioned that some of these settings are possible from the IAM. When we are talking of user access control, we say, you can do this from IAM. So we make sure people do not have access to what they are not supposed to, and other information like that, right? Okay, when we want to know allocate the right access to people, we still go back to IAM. So you see that when it comes to managing digital identity on the cloud, IAM is very important. IAM is critical. So key role of IAM in cloud security, it ensures the right individuals and entities access cloud infrastructure. IAM is in charge of ensuring that the right individual and the right entity can access cloud resources. Okay? IAM establishes a secure perimeter across cloud resources, protecting against unauthorized access. IAM establishes a secure perimeter across cloud resources, protecting against what? Unauthorized access. Okay, all right. Somebody please help me attend to Evanya. She said she didn't get the questions. Please help me type it in the comment section, guys. All right, thank you. Importance of IAM in cloud security. So, one, we have protecting sensitive data, right? IAM helps prevent unauthorized access to data stored in the cloud by ensuring only authenticated users can access sensitive information. Next, we have reducing risk of data breach. With IAM, organizations can minimize exposure to limited access based on roles and responsibilities. So with IAM, we can actually configure things and make sure that we reduce the risk of a data breach. Next, we have compliance and regulatory requirements. So you can actually meet up with compliance and regulatory requirements like GDPR, HIPAA, PCI DSS. Okay, so yeah, let's just move. Okay, next we have key component of IAM. Key component of IAM, right? We have identification. So IAM assigns a unique identifier to every user, not just user now. On the cloud, when we are talking about user, we are talking about different entity, right? So we have user, we have services, and we have devices. So IAM is in charge of assigning unique identifier to all of this. So it is not just human being alone. We need to make sure that the cloud services, right, are uniquely and properly identified. So essentially for tracking and managing identity in the cloud. So IAM is in charge of what? Of tracking and managing identities in the cloud. Okay, then we have authentication, right? So methods of authentication are IAM such as passwords, security tokens, biometric and MFA. These are all part of IAM. These are all component of what? Of IAM. So for example, we could the use of OTP, right? Use of use of TOTP, which is time-based one-time password applications of physical security device. So another component, okay, MFA is multi-factor authentication. So your 2FA is an example of MFA. Adefioye, thank you very much, Boluwatife, for helping out with Evania. Yes, MFA is multi-factor authentication. So you could have multiple layer. Two-factor authentication is just two layer. You could have three-factor authentication. You get three layer and so on and so forth. So the general name is multi-factor authentication. That means you are taking more than one factor, multiple factors. You get. So next component we have authorization. Okay, so controls what users can do within the cloud environment, defined through permissions, through roles and policies. So types of authorization, right? We have role-based access control, RBAC, and attribute-based access control, ABAC. So next we have what? Accountability. So you see that a lot of problems, a lot of issues that we've been discussing, IAM is actually what? Dealing with them. Okay. Um, Helmari's gadgets. No, you can't use IAM to track armed robbers' location. Okay, very funny. Okay, accountability, right, involves logging and monitoring activities, ensuring users can be held accountable for their action within the cloud environment. So you need to make sure that people are accountable for every action carried out on the cloud. And this is handled, this is one of the components of what? Of IAM. So if you are doing anything, you are tracking it down. Everything you are doing, you will be held accountable to everything you do on the platform, thanks to IAM. Okay, now best practices when it comes to IAM, cloud IAM best practices, right? One is what? Least privilege principle. Very important. Least privilege principle. So limit users permission. Excuse me. Limit users permission to only what is necessary for their role. So now it is possible to do all of this in the cloud, all what we've discussed, right? Authorization, accountability, identification, authentication, protecting sensitive information is part of the benefit and other stuff like that. But then these are all possibilities. Do you understand? These are all possibilities. These are all possibilities. That means somebody has to make these things happen. So, and in order for you to make these things happen, you must follow a couple of what? Of best practices, such as what? Least privilege principle. So limit users permission, limit users permission only to only what is necessary for their role. Then you need to what? Regularly review and adjust access level as roles changes. Okay, so somebody might be promoted, somebody probably might also be what? Demoted. Somebody might lose their job, somebody might get hired by another company, somebody might resign. You get? So you need to make sure that you keep updating your IAM to suit all of this. You regularly review and you adjust. Okay, role-based access control, right? So you need to follow role-based access control, which involves define roles based on organizational function and assign permissions accordingly. Okay, so define role based on organizational function and assign permission accordingly. Okay, for example, you need to separate roles for administrators, separate roles for developers, and separate roles for what? For end users. Okay, next is attribute based access control. So provides final control using attributes. For example, department locations to define access policies. So it is useful for dynamic cloud environments where access needs can change frequently. Attribute-based access control is very, very useful in dynamic environments, right? Then we have multi-factor authentication, MFA, right? Essential for high-value account and administrative load. So adds a layer of what? Of security by requiring additional verification factors. So okay, the user's password have been stolen, but then the attacker cannot proceed because there's another layer of authentication. Okay. Next is what? Unauthorized access and credential theft. Okay, sorry, we are done. No, 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 sorry. Okay, we are done with best practices. Now we are in threats and challenges to IAM. Right. So, but before we take this, let me quickly go through the comments. Okay. Obi winning plenty work. Plenty work inside cloud. Interesting. Yes, yes. Okay. Cloud computing is a course on its own. Yes, it is a course on its own. But then you will notice that most of our conversation in this class, in this session, has been tailored towards securing the cloud. You get it is tailored towards security on the cloud, right? Okay, how do you think as a security person on the cloud? You get. All right. Yes, thank you very much. Yeah, you could use Face ID. Well said, Ukoli, Grace, um, Jimmy, another layer of authentication like asking secret question. Well said. Um, Pamela cloud is really wide. In fact, it's really cloudy. All right, very funny. Yes. Okay. Thank you very much, Adefioye. All right. All right. Thank you, guys. Yes. Okay. So let's get back to it. IAM threats and challenges. So unauthorized access and credential theft is one of the challenge when it comes to IAM. So threat actors can exploit weak or stolen credentials to gain access to cloud resources. So the attack vectors include phishing, brute forcing attack, and credential stuffing, right? And then you can easily tell me that with what we've discussed so far, you know that some of this can be removed when you set in what? MFA, right? Add another layer of security, right? If you steal my password, you probably have not been able to steal my face. You probably have not been able to steal my retina. You probably have not been able to steal my fingerprint. Okay? All right. Then for brute force attack, you know you are not supposed to use easily guessable password. You get? All right. Um Insider threat. Yes, this is also very important. Insider threat, right? Employees with excessive privileges can pose risks if they misuse access. So that is why it is very important that you restrict access to only what an employee is supposed to you restrict an employee's access to only what they are supposed to have access to. You don't just give them overly excessive privilege on the cloud platform because you can't trust human, right? At the end of the day, we are humans, right? Somebody can choose to what? To misuse their access. Somebody can feel hurt and decide to betray the organization. So you need to have a solution against this scenario. So how do we mitigate this? We mitigate by what? Regular audit. So it is when we audit the cloud environment that we know, okay, this user, why is Mr. Olabisi having excessive permission? That's when we ask the question, and that's when, if there's no proper answer to it, we reduce his permission level. Then access review, also important, and privilege management. We also manage the various privileges in the cloud. Okay, then we have shadow IT. Shadow IT, right? Employees using unauthorized cloud services without IT knowledge, leading to unmanaged and unsecured access points. Okay, so solution to this is what? Implement identity governance tool and what? Cloud discovery solution. So very important. Shadow IT, right? You have something in your cloud environment, and then somebody is bringing something else that could expose the organization, that is definitely going to expose the organization to risks without letting the organization know about it. Get then IAM complexity in multi-cloud environment. So managing IAM across multi-cloud providers can be challenging due to different IAM models and policies. So it is different. The IAM environment policies and procedures is a bit different across these different cloud service providers. So for AWS, it is different. For Azure, it is different. For GCP, it's different. For DigitalOcean, it's slightly different. You understand? So what is the solution for this? Use centralized identity management tools like Okta for Azure AD or Azure AD for unified control. Okay. All right. Olabisi, thank you. Can we have real life example or hands-on? Okay, this is introduction, so we are touching a lot of fundamentals, so it involves a lot of theories. Yes, it involves a lot of theory. All right, so just bear with us. Right? So what I examples of IAM solutions and tools, we have single sign-on, right? So if you visited some web pages, you probably have seen SSO, single sign-on page, right? Maybe you log in one page, and then every other account on that platform aligns with. So every other application on that platform, you have access to every other application on that platform just from a single sign-on. So simplifies access by allowing users to log in once and gain access to multiple applications, reducing password fatigue and enhancing users' experience. So, okay, why do you have to create 10 strong password for different applications from just one organization? Why not just have the user create one password which will be valid for all other applications belonging to that um belonging to that what is the word now? IT firm, belonging to that IT firm. You get belonging to that organization, right? So this will help to reduce password fatigue. Yes, it's a thing. Password fatigue is a thing, right? We have a lot of online presence, right? So it is hard to keep track of the various complex passwords Okay, can you guys hear me now? Please, can you hear me? All right, thank you. Sorry, my network stopped for a minute. All right, so then we have federated identity management. So this allows users to access multiple systems using a single identity, often facilitated by third-party identity providers. So standards such as SAML, Zero Auth, and OpenID Connect for secure identity sharing across cloud applications. Okay. Then we also have zero trust model. We have zero trust model. All right. So zero trust model assumes no user or device should be trusted. You don't trust anybody. Okay. Zero trust model assumes no user or device should be trusted by default, even if it is inside the network. All right. So enforces strict identity verification and continuous monitoring. So zero trust model is very, very important. It's a very useful tool. All right, so thank you guys. With this, we've been able to touch the fundamentals of cloud security, right? I know it is a lot of information. I know it is a lot of gisting, it's a lot of reading, but yes, we just have to do this. We need to make sure that the theory is in place. So as we move to the next phase of this training, which involves projects, a lot of the information that we've shared in the last couple of weeks, in the last couple of days, right, is going to be useful, right, even as we walk through some projects together, right? So I will be making reference to some of this information, and then everything will make more sense. So the goal of what we've been doing so far is to build a knowledge base, right? So sometimes you notice that I do not ask, do you understand? I ask, are you following? Right? The point of understanding is coming very soon by the time we get our hands dirty. So thank you very much, guys, for your understanding so far. We are beginning to bond. I mean, we started on a very rough part, but now I'm happy that you guys are um, making beautiful contributions, and yeah, thank you very, very much. Amen. Amen. Thank you, Joy Alonge. Thank you, Hot Topic. Um, yeah. Okay. Thank you, Gift. Thank you for the compliment, Gift. All right. Thank you, KG Legend, Caroline. Yes, so much for today's class, Pamela. Yes, I know it's a lot. I know. But trust me, very soon, everything is going to click. We will connect all the dots very soon when we jump on our project. All right. All right, Baron. Yeah. Okay. All right. So thank you all. Yes, we will be back on Tuesday where we attempt our very first project, guys. So please come ready for Tuesday. Please get enough data. Get enough data. I'm warning you ahead, please. 10 gig, 20 gig, just get it ready. You get, because we will be getting our hands dirty. Yes, I figured a lot of you guys still have problem with setting up your virtual environment. So that is what we will be starting with, right? We'll set up, let me just give you a hint of what the project will look like, right? We set up a virtual environment, a virtual hacking environment. For some of you who don't have your Linux system, we'll set it up, add a couple of machines to the environment, okay? And then after that, we are going to set up multi-factor authentication for a Windows system, right? We are going to be talking about something called RDP, right, which allows you to remotely connect to a system. So as I'm here in Abuja, I could be using a system in the United States of America. So how do I do this? I connect to it using a protocol called RDP. So now, remember we said multi-factor authentication is very important, right? So we'll set up multi-factor authentication. So anybody that wants to use the system remotely, they will have to supply a code, right? So that will be an interesting project. I'm just giving you guys heads up so you prepare. We have a lot of interesting stuff coming up. And then also you guys have heard about firewall, right? We've spoken about firewall. So we'll be setting up a firewall for our local network environment. Thank God, remember virtualization, right? We can virtualize things so we can have 2 3 computers inside our computer. So we'll replicate a network, right? And then we are going to segment the network, and then we are going to put a firewall to check what is going in and out of that network. All right, so those are the 3 first projects we will be getting to. So please, I beg of you, make sure you have enough data, right, ready. Make sure your laptop is ready for this project, right? Yes, like I said, you should have more of me on the group. Yes, I'm working on that. Yeah, all right. And also, since it is practical, right? We are a lot, right? I have close to 1,000 students. That's a lot, right? So please let's try. And there are some problems we know are going to come up, like data might be faster for some persons, data might be slow. So please, we will have to bear um when those problems start, right? Just calm down. There's nothing wrong. Things will work. Just calm down. Yeah. So, all right, guys. Thank you very, very much. Okay. So, thank you all. See you in the very next one. Peace.